Hello, in this video, we will be seeing how to build a data structure that represents a least recently used cache mechanism, and we will be building a solution in JavaScript and also compute the time complexity and space complexity of the solution that we will be building in JavaScript. Before jumping into the solution aspect of it, let us first try to understand what the problem statement is. And the problem says that given a input array that looks something like this, LRU cache, put get, and along with that we are given some values here. What that means is we will be having a data structure that will be having three functions. One function is the constructor itself that will be initialized with a capacity. Another will be a get function to get a specific key, and we will be using another function called as put to put value against a key in this data structure that we'll be building. This is what represents the input that we receive. So for LRU cache, we are saying create a cache instance with a capacity of 2. Then we are putting some data and then we try to get some data. If you don't have any data to receive, you will just return -1. Otherwise, you will return the value. And for putting, we will check the capacity of the LRU cache that we have built. And what this LRU mechanism means is that if you have least recently used a specific key, we just discard it whenever we reach the capacity of our LRU data structure. And after evicting the key, we will make sure that we make space for the new key. That's how this mechanism works. We never want to exceed the capacity of our cache, and with the limited cache that we have, we will just keep on making sure that if you have recently used, that means you either put the data or you try to get the data. That what means by it is being recently used. And if you don't do these operations, then it is less recently used. So then you see which is the least recent one and then just discount the value that you have with you. And that's pretty much it in terms of the problem statement. Now with respect to the solution aspect, as we are going to build this solution in JavaScript, I will try to take advantage of some built-in data structures that we already have in our arsenal and try to come up with a solution. And for solving this specific use case, the data structure that comes in my mind is a map. So we will be using a map to try to replicate this data structure that we want to construct for LRU, and then tweak it in such a way that it fulfills the criteria of get, put, and the eviction aspect of it when the key is least recently used. So for the get and put, we will be using the operations of set and get within the map itself that have this inbuilt functions. And for the second part that is related to eviction, we will compare the size of the map with the capacity that we want to check. So this will get compared with our capacity, and then we will see if the capacity has been reached or not. And if the capacity has been reached, we will be deleting the recently used key that we have with us. And that's pretty much it in terms of implementation. So we will be having a constructor here which will say LRU cache, and we will be receiving a capacity for that specific cache instance that you want to create. What we will then do is basically put the data within the instance. So we will say something like this dot capacity is going to be capacity that you have received when you initialized, and we said we are going to use map and try to take leverage of this set and get functions that are built in within the map data structure. So I will say this dot map is equal to my new map that I'm going to have, and with this new map I will try to use set and get. So when we want to have a get against this LRU cache, the simplest thing that we can do is this dot map dot get whatever value we have against the key, and this value is something that will be returned from our side. So we will just get the value from this map and return it. And for the put operation, we can just say this dot map dot set key comma value. So this covers the first basic aspect, wherein we leverage the built-in map for putting data in a LRU and getting data from the LRU. Now comes the aspect of also making sure that if you have not received a value, then you will just return -1. And to do that, what we will just do is within this get prototype, we will just add a check here saying if this dot map dot has that specific key, then it's all right. You find the value and then you return whatever value that you have. If you don't have it in the map, then what you can do is just return -1. So this will cover the use case of returning -1 when you don't find the element within your LRU, and when you find, you just get it and return it. So this covers most of the use case to get the data and set the data and initialize with capacity. Now comes the next aspect, wherein we said we will make sure we evict in a correct manner. Now, to be able to evict in a correct manner, we also need to make sure that when we put data into this LRU cache and when we try to get data from this LRU cache, this means that it is getting used. So we need to make sure that the recently used one stays recent in our map as well. And because what we said is we will be using this map itself to evict, and to evict we will be using the iterators that map provides, and to make sure that if the key is recently used, then it doesn't get evicted as a least recently used key, we will have to refresh the key within the map itself. And to do that, what we will do is when you get the key, getting the key means you are recently using it, and if you are recently using the key, we will get the value from the key, then we will just delete the key, and then we will reset the key within the map again. So we will say this dot map dot set key comma value. This will refresh its position within a map and keep it recently used as kind of a tracker. And similarly, when we try to put the data, then also we want to make sure that it is getting recently used. So if you already have the data, if you just do set, the existing key will get overridden. But what we want to do is, if you are doing get and put, we want to make sure it is refreshed so that you know that it is recently used. And to do that, what we can do is something like this. If map dot has the key that you are looking for, then you will just do this dot map dot delete the key itself, and then you set the value. So this will refresh it, and it will make sure then when you are trying to iterate your map to delete the least recently one, the key doesn't get deleted because it's refreshed. You reset it, you delete the old occurrence of the key and you add a new occurrence of your key in the dictionary of a key map value that you have with this inbuilt map that we are using from JavaScript. And then comes the aspect of eviction. When do we evict? So what we will say is, if this dot map dot size, you will keep on putting data into your map, and there is going to be a capacity. We don't want to exceed that capacity, and if you exceed that capacity that you have, then we want to evict. And eviction is going to be evicting the least recently used key that you have. We'll just say this dot map dot delete and find the first key, and we will be using an iterator to just get the first key. So this says something like this is dot map dot keys dot next dot value. So doing this will just give me the first key in my key value pair dictionary of the inbuilt map that we have, and then we just delete that specific key which we have found. And that's pretty much it in terms of implementation. Now in terms of the time complexity that is going to be involved here, if you are going to be putting data and getting data, the time complexity involved will be based on the number of activities that we are performing based on your input array, and the time complexity will be bigger of n, because n number of operations will take n time to get the operations completed. And in terms of the space complexity, it's going to be bigger of something, and that something is going to be this capacity, because based on the capacity you will be having data, and you will just keep on updating the data that you have either by evicting the old keys or setting the keys within this dictionary map that you have. And that space will never exceed the capacity, because when we try to exceed the capacity, we make sure that we just delete the first key. So it will never exceed the capacity. It will exceed for a moment, that it's going to be capacity plus 1, and then we just delete it again, and then it comes back to capacity. So big O of capacity plus 1 being a constant, it just becomes big O of capacity itself. And that's pretty much it. Thank you for watching. Please like and subscribe.